the next session on effective radiation oncology physics.
We're a little bit ahead of time.
Right.
Do you want to see if there are questions?
Okay, we are ahead of time. We'd be glad to entertain any questions or comments. We have a question. Hold on just a minute. Would you come to the mic? Somewhere's the mic, yeah.
Okay, Cristiana Peroni from Italy. Torino, in fact, it's one of the dots on your map.
Yeah.
Yes, how much do you value the solution of numerical problems? I mean, putting in numbers into problems and getting a result for it without, without heavy support. I mean, you're just sitting there, getting the formula out, putting numbers into the formula and getting the right solution, the right answer.
Okay, a very good question, and one that we struggle with. Basically, we very often teach, I'm going to use it, the equations, before we have taught the concepts. And I think we've all probably experienced this at graduate school and other places too. Now, there is the need for the quantitative aspect, the ability to solve the equations. This need is probably greater for physicists and graduate students than it is typically for the radiology resident. The problem there, if we are teaching the equations without the understanding of the concepts, it is not something that can be properly applied in the real world. Yes, it's good for doing examinations, as examinations very often focus on. But again, what we attempt to do is, shall we say, get an understanding of a concept. I'll go back to the inverse square effect, for example. Visually, we can teach that as the dispersion and spreading of an X-ray beam. That makes sense. Then go back and do the quantitative aspect. Thank you for the question, yeah.
Just want to point out something about the cognitive experience that I'm sure everyone will agree is obvious as soon as it's pointed out. Any single effective learning experience is going to involve multiple levels. I mean, for example, physical reality, you can teach someone a lot about CT by bringing them into a CT scanner and scanning. But that's going to involve verbal interactions between the teacher and the student. If you were to take, if one were to say, the physical interaction is all that's important, we can do this with verbal interaction, take a student put them down in front of a CT scanner and say, learn CT, I'll see you later. I think we'd all agree. So it's not so much a matter of each level of different kind of learning experience, but the most effective learning experiences make use of multiple levels of the cognitive experience.
Okay, Dave, thank you very much for that. And that's a discussion that he and I often have along those lines. Now, think back, look back in your brain for just a moment into the gray zone to the cognitive experience. Physics reality is at the bottom in yellow. You see it? Now, moving on up, there is that where it is still visualization with expert guidance. That's the critical thing, and I think that's where you're focusing at there. Now, as opposed to an isolated lecturer off somewhere with nothing, no connection, talking. Right, yeah. That human guidance is very critical. Other questions? Okay, we will transition from medical imaging to radiation oncology, effective education.
Good morning. I'm Jeff Ibbott, and I'm moderating the second half of this session. And as Dr. Sprouls mentioned, the second half is going to be focused on radiation oncology physics education. And just like in imaging, we're in the midst of an evolutionary process in our education and training systems, and particularly in our recruitment of new physicists into medical physics. You know, in the past, we've had a great deal of variety in the way people come into the field. I'm sure if you take a poll of a dozen medical physicists out of the exhibit hall here, say, or one of the sessions, you'd find a huge variety in the way we all came into the field. And sometime when I don't want to bore everybody with my own personal story, but just like everybody else's, it's probably not a traditional story of coming into medical physics. And we've remarked on this over the years, that because of this variation, when people come to some sort of an evaluation process, and the first one that comes to my mind, for obvious reasons, is the ABR certification exam, we see a huge variety in performance on the certification exam. And so there have been efforts through the AAPM, through CAMPEP, and through the ABR to try and bring our educational processes more in line with each other, to make them more consistent. At the same time, there's concern that by doing that, we're eliminating a rich source of knowledge and different perspectives if we make it more difficult for people to enter medical physics from other scientific fields, other physics fields and other non-physics scientific fields. So this presents a real challenge for graduate programs to balance those two issues, making our training programs more consistent and uniform and preparing people so that they perform well on certification exams without closing off the pipeline to people from other branches of science. So to describe to us today how different programs have addressed this issue, we have three medical physics graduate program directors who are each going to describe their programs and address these concerns. So the first speaker in this session is Jay Burmeister from Wayne State University, who in Detroit, who is going to come up and tell us about his program. Jay?
Thanks very much for the introduction. I'm Jay Burmeister, and I want to thank you for inviting me to give this talk. It's kind of an honor to give a talk to all of you about education, and I want to thank all of you for showing up to an education session. I know there are a lot of great concurrent sessions, and I think it's nice to see this many people interested in an education session. So it's probably not quite as sexy as MR Linux and carbon ions, but those of you who know me know I'm fond of saying that the human is much more important than the machine. So what we talk about here has a profound impact on who comes out into this profession and who's operating that equipment and treating our patients in the future. So with that backdrop, and maybe bringing up the next set of slides. All right, so my talk is titled Radiation Oncology Physics Education at Wayne State University. But I want to start with a broader view, and I want to look at some of the issues that are relevant to medical physics education as a whole, and then sort of narrow down on what we do within our program and our approaches. So I think I can summarize my talk with three questions. Who are we training? How are we training them, and are they successful? So I'll address each one of those in turn. And I think when we get to the third one, if we determine that our graduates are not successful, then I think we need to go back and evaluate the first two. Are we bringing the right people in, and are we training them well? So I think the field, the profession as a whole, is going to determine whether these graduates are the type of people that they want to hire and if they're trained well. So we'll start with the first item, which is who are we training? This picture comes from TG 133. I'm sure many of you are familiar with this. These are the pathways that were presented in TG 133 into the profession. And I think this is still relevant today, at least this year, with the exception that these percentages are no longer accurate. But what TG 133 said is this should be the standard pathway, and everybody should go through the residency, which I think we've all agreed is an appropriate thing. The one issue that I think many of us had with this particular picture is this statement right here, which says equivalent. And I think many of us would agree that, at least in one sense, this is not equivalent. Someone coming in with a physics PhD or physics master's does not have the didactic background that someone with a medical physics degree has, and therefore if they want to get that education within the residency program, then by definition they get less clinical training than the person who already has that didactic training. But that issue now has been remediated, I guess, with the advent of Report 197S, which specifies the core components of medical physics education that someone coming into the profession must have, and you're only allowed to take 2 of those now during your residency program. So I think things are equivalent now with the advent of that. So I put this slide together, which is, as we look to the future, what pathways do lead to ABR certification. Those are illustrated here in green. Those in red still exist, but they don't lead to board certification. And this is an interesting one which used to exist, the path of the physics MS into ABR certification. However, it appears now that the CAMPEP certificate process, at least, will not be open to the physics MS. And so while there is an arrow to the CAMPEP MS or PhD, it appears at this point there is no arrow through the CAMPEP certificate into the residency program. So if you have concerns about that, now might be the appropriate time to voice your concerns. And I guess as we look at the future of the profession, who do we want to enter the profession? And I think there's broad consensus that we want to continue to usher in these alternative pathway entrants. The people from physics, from computer science, from engineering bring unique perspectives to the profession that have benefited us greatly, both in clinical practice and particularly in terms of research. And this is something that we don't want to cut off, so we want to foster this alternative pathway. The second question, what degrees and training should they have? I think that's pretty well standardized now. Report 197 specifies the curriculum for graduate education. Report 90 specifies the curriculum for residency education. And 197S for certificate programs for those coming in through the alternative pathway. And then the third question I have here is how many should be certified, which is an interesting question because, as we all know, there will not be enough residency spots for all of those who would like to get certified in the near future, at least. And so we will most likely be moving to a stage in which we'll have a certain population of our physicists board certified and another population of our physicists not board certified. And the question is, should graduate education programs in particular do anything about this, and if so, what? And that is a topic for several other talks, which I wouldn't have time for here, so we'll leave that question hanging. And again, thinking about what defines us as a profession, what are the pros and cons of standardization of medical physics education? Certainly there are merits to standardization, and this is clear for a variety of reasons. We want to make sure that everyone has the same didactic background, the same core competencies, the same clinical training. And it's clear that our physician counterparts value this. They would not allow a PhD in biology to enter their residency programs, even though they may know much more about the biology than the person coming out of medical school. But there are certainly advantages of standardization. And certainly the converse is true as well. We absolutely do not want to standardize the profession such that we lose the unique perspectives brought in by those coming in from physics, engineering, computer science, just to name a few. So we need to concentrate on providing appropriate didactic, clinical, and research training as we think about who we want to bring in to the profession and how we want to make sure that they have the right tools as they move forward. So with that, I'll move into who are we training, specifically at Wayne State University. And I thought it would be interesting to go back for the past 6 or 7 years and look at our demographics. And so I called this data from our matriculating students from the last 7 or 8 years. and about 70% of our incoming students have a bachelor's degree in physics, 20% in engineering, and the remainder is made up primarily of math and computer science. Greater than 50% of them have at least one graduate degree, so these are not necessarily your typical students coming straight out of undergrad. And maybe the most interesting fact, and one that will change certainly in the future once we have more certificate programs, is that 1 out of 5 of our students entering the master's program already has a PhD in physics. And looking at this data from this last number of years, these people had no requirement that they had to come through our master's program, but they chose for a variety of reasons, whether it be they felt that this was a better preparation for them or whether it would make them more marketable for a job or residency, that they do this. And I think they have been well prepared and well served by choosing to make that decision. But as I said, those people will be quite happy to only have to do the certificate coursework in the future. So as we look at demographic changes in medical physics as a whole, I think the question is, will the residency requirement change these demographics? And specifically, will the PhD in medical physics still be appealing? When you're asking someone to spend 5, 6, 7 years doing their PhD, and then you tell them if they want any clinical component, if they want that safety net or that component of their job that makes their research relevant in a clinical realm, then they'll need to do a residency after that if they want to get board certified, and so there's another 2 years. And how many people at the beginning of that are going to say, no, that's too much, I'm not interested in spending that much time in school and training. Secondly, will PhDs in physics still find it worthwhile? I've got a PhD in physics, but now I have to get all of my coursework in a CAMP-EP accredited program. I have to find a certificate program, move there, take the certificate coursework, and then there's no guarantee that I'll get a residency at the end of that, just like there's no guarantee that the PhD in medical physics will have a residency at the end of it. So the question is, will enough of these excellent people out there coming into either PhD programs in medical physics or coming from PhDs in pure physics still be interested in this pathway? And thirdly, will more PhDs be ABR certified due to residency selection bias? And the interesting stat here that's being thrown around at this meeting, maybe you've heard it and maybe you haven't, is that the graduate programs produce a 2-to-1 ratio of masters to PhD. The residency programs bring in a 2-to-1 ratio PhD to MS. And that leaves many MS students who are very specifically ones who are interested in clinical work without the means to get themselves board certified to do that clinical work. So it's an interesting conundrum that we have for ourselves here. And again, another issue I don't even attempt to solve within this talk. So let's move into how we train them. We've talked about who we're training. First and foremost, we're physicists, and that's the thing that we attempt to keep in mind within our program as we teach our students, and that physics is not about recursive plug and chug. It's not about memorization and regurgitation. Education, as Albert Einstein said, education is that which remains once you've forgotten everything you learned in school, and that's kind of the principle that we start out with when we think of the fundamental education of the students in our program. And this is really the difference between instruction and teaching as well. If I instruct you, you can tell me what I told you or do what you saw me do, but if I teach you, then you have the tools to go and solve any problem that you haven't seen before. So these are some things that we emphasize specifically within our program, and we build our practical concepts, our clinical concepts, on a foundational theoretical coursework. Will our students go to their office in the clinic and at some point and derive the Klein-Nishina coefficients or something like this? Absolutely not. But it's important for them to have derived these theoretical constructs to begin with so that they understand dependencies of things. How does this depend upon that? How does this depend upon that? And what were the assumptions involved in the original derivation so that I can know when I've violated those assumptions that this formula no longer holds? So I think it's important that people understand the basic theoretical background in order to appropriately apply the practical concepts. Another thing we concentrate on is effective teaching methodology. Some of you may have heard of the peer instruction concept by Eric Mazur out of Harvard. And that's something that I recently incorporated into our intro radiological physics course with, I think, very positive results. With a big emphasis on not just me standing up and lecturing here, but giving them an opportunity to get into groups and solve problems together and teach each other what they just learned. Okay. So the other thing we've incorporated within that course is technology. We now have streaming online audio and video. They can watch last year's lectures before this year's lecture. They can watch this year's lecture as many times as they like. And at first I was worried that this may deter them from coming to class, because I know the med students don't come to class now that they have this option. But I was very surprised to find about 6 or 7 years ago when I started doing this that all the students still come to class. So, in terms of curriculum, AAPM Report 197 specifies relatively well this curriculum, and it's listed for you here. I see no reason to repeat all of this. In terms of clinical training, it's also specified in Report 97 that the educational program is not the appropriate place to provide this, as I think we would all agree. That is for the residency. However, it is valuable to teach this, certainly the fundamentals of the clinical coursework within the program. We also offer hands-on laboratories and internships, oral review sessions, which I'll come back to in a moment. And one question that I've asked our faculty and students is, once residencies are required, should clinical training be minimized in educational programs? And the answer has been a resounding no from our people for two reasons. One, they feel that this puts legs to the didactic coursework that we've taught them. And two, that this makes them more marketable for residency positions when they go out. And one other thing I want to mention in the curriculum are what Pete Dunscombe has been referring to here at this meeting as soft skills, communication, leadership, and those sorts of things. We've incorporated these into a seminar course that we have, where they learn how to give a good research presentation, how to write a grant, how to write a good manuscript, leadership skills, effective communication, professional issues, how to interview, history lessons, that I feel every one of our students should learn about the Riverside incident and all of these other things that have happened in the past. We incorporate this set of information could be labeled a bunch of stuff to help keep our graduates from looking stupid on their first day in the clinic. Medical terminology, radiological anatomy, medical research ethics doesn't really fall into that, but I guess could, depending on what they do when they go out into the clinic. And finally, in that seminar course, we also do a set of oral review sessions in which we get our students together and one at a time we mercilessly grill them with questions in front of their classmates. And it's been a very rewarding experience for them, I think. And it's something that's prepared them well for job interviews and I think for the oral board exams as well. And this is a little bit about how we prepare our students for the board exams. We offer everything that's going to be on ABR Part 1 prior to that ABR Part 1 date, so we know they're well prepared for that. The oral review sessions, I think, get them well prepared for the oral exam. And we also run an annual oral exam prep program with mock orals, which we encourage them to come to. And lastly, how do we gauge success? And I mentioned at the beginning that we should be gauging success based on what happens with our graduates when they come out. And I thought, what are some of the metrics that we could use? Certainly employment success is a valuable one, but I think most programs could say this, that all of their graduates are ultimately getting jobs. It's a question of how long it takes them. So it's very difficult to tease any real statistical information out of that. But what we do have is good statistics in terms of how many are going into residencies. And these numbers here, I actually estimated before I got to the meeting. Now I know the real numbers. And in the last 3 years from the SDAMP survey, CAMPEP medical physics grads were getting residencies at a 12%, 12%, 24% clip over the last 3 years. PhDs, I think, was 16, 20 something, and 34. So on average, this number actually probably is around 15%, and this one's about 30% over the last 3 years. For our PhD grads over the last 5 years, 2/3 of them have been able to get a residency, and for our master's students, more than 1/3 are able to get a residency. So I found that very encouraging, and I'm happy to tell our students that, but I'm still a little bit disappointed to have to tell them that only 1 out of 3 of them is going to be able to get a residency. So that's something we certainly need to remedy in the future. So as we look to where we go in the future, I think it's important for us to consider what the job market needs, how we're training these people, how many we're training, and whether we're giving them the appropriate pathways into board certification. And the age-old question that plagues us: are we a science or are we a profession? Are we scientists or are we technicians? And what really is it that defines us as a profession? What do we want to define us as a profession and make us valuable to the hospital? And work backward from that. So if we answer that question, we can work backward and determine who we want to bring in and how we want to train them to make sure that we are continuing to add that value to the medical community. And with that, I thank you for your time and your patience. Thank you.